So today in college algebra, we're going to be looking at graphing cosecant and secant. All right, now I've been telling you for over a week, if you can graph sine and cosine, then cosecant and secant should be pretty easy. Okay, if you remember for cosecant, this is the first one. Cosecant is the same thing as 1 over sine. So what we're going to do is we're going to graph the sine function instead of the cosecant function. So when we're graphing the sine function, we start with the period, which is 2 pi. Half of that is pi. Half of that is pi over 2. And 3 times that is 3 pi over 2. Okay, for the sine function, the sine graph starts at 0, goes up to 1, goes back down to 0, goes down to -1, and then back up to 0. All right, so now let's look at our points in terms of sine and cosecant. Okay, we had 5 points that we graphed. We graphed at 0, we graphed at pi over 2, at pi, at 3 pi over 2, and at 2 pi. So now what we're going to do is look at those points at those intervals in relationship to cosecant and sine. So let's look at sine first. At 0, we had the point 0. At pi over 2, we had positive 1. At pi, we had 0 again. At 3 pi over 2, we had -1. And at 2 pi, we had 0. Well, if cosecant is 1 over sine, we're going to put 1 on top of all these numbers and see what you come up with. So for cosecant, spelled it wrong. Cosecant, 1 divided by 0 is undefined. You can't divide something by 0. All right, it becomes undefined. So we got to put undefined for there. 1 divided by 1 is 1. 1 divided by 0 is again undefined. 1 divided by -1 is -1. And 1 divided by 0 is undefined. So what we're going to do is we're going to graph the sine graph first. And we're going to make it a dotted line. By making a dotted line, it means that you don't see it in your final product. It's just there as a guide for the real graph. On the real graph, what we're going to do is at all the undefined spots, at 0, at pi, and at 2 pi, we're going to put asymptotes because those points for cosecant are undefined. And you can't have points on those spots because, well, it's undefined. So we have asymptotes here on these 3 spots. Okay, change the color here real quick. Now, for the other spots, at 1 and -1, we're going to put points at the same spots that they were points on the sine graph. And what we're going to do is we're going to go up in a parabola type shape. It's bounded by the asymptotes. And then a parabola that goes down that again is bounded by the asymptotes. And that is your cosecant function. Okay? So as you can see, to graph this, we're going to graph the sine function first, and then we're going to graph the cosecant on top of it. All right, let's look at the secant function. Now secant, let's go back to blue. Secant is equal to 1 over cosine. So let's graph the cosine function first. So again, we start with our period and interval. So we have 2 pi, pi, pi over 2, and 3 pi over 2. So the cosine function begins at 1, goes down to 0, to -1, to 0, and then to +1. So let's take those points just like we did in the last problem. So we had 0, pi over 2, pi, 3 pi over 2, and 2 pi. So we're going to make our little chart here. So we have cosine, oops, let's finish the chart here. So at 0, cosine is 1. At pi over 2, cosine is 0. At pi, cosine is -1. At 3 pi over 2, cosine is 0. And at 2 pi, cosine is 1 again. So if secant is 1 over cosine. Again, we're going to make these reciprocals. So we got 1 divided by 1 is 1. 1 divided by 0 is undefined. 1 divided by -1 is -1. 0 divided by 1, or sorry, 1 divided by 0 is undefined again. And 1 divided by 1 is 1. So what we're going to do is we're going to graph this cosine function as, again, a dotted line. And all the places where it was 0, we're going to put our asymptotes. Again, bounding the graph because at those spots, the graph is undefined. All right? And then where we had points and the peaks and the valleys, so there's a point here at 1, at -1, and at +1, we're going to put our parabola type shapes. Now, secant is a little bit weird in terms of the fact that we're only still looking at one period of the graph, so we're cutting off the front end and the back end of the graph. Okay, technically, this pattern would just keep repeating itself over and over in both directions. The same thing for cosecant. Okay, you'd have those parabola type shapes just repeating over and over and over again, up and down throughout the entire graph. That's all it would be. It's just a repeating version of that. Just kind of like the cosine and sine graphs are just continuous waves. Okay, so that is it. You're going to graph the sine and cosine graph first, including all that's period changes or amplitude changes or phase shifts, and then on top of that graph, you're going to put the asymptotes and then the parabola type shapes for the secant and cosecant. So let's look at what that looks like in real life. So what I'm going to do is I'm going to think about graphing this instead of cosecant. I'm going to think about graphing this as a sine function. So just like we did last week, first step is do the period. Well, the period didn't change because nothing was multiplied or divided to the x value. So it's still going to be 2 pi. So put down my intervals for my period. Okay, next, my phase shifts. Well, I'm going to go to the left by pi because this is being added to the inside of the function. So it is a horizontal shift, and I'm going left by pi. Now, pi is 2 intervals from 0 to pi, but I'm going left by 2 intervals. So I'm going to end up with -pi and -pi over 2 as my period intervals. Now, you have to put those down as a reminder. That is part of the grading process for these problems. So now I know horizontally where I'm going to start. Now let's figure out vertically. So sine is being multiplied by 3, and sine starts at 0, and 3 times 0 is 0. Okay, so my first point is going to be at 0 and -pi. Now for sine, I go up by the amplitude, which is 3, then go down by 3, go down by 3, and go up by 3. Now I'm not going to draw a solid line graph. I'm going to draw a dashed graph because this is really a cosecant function. Okay, now all the parts where it would be at 0, which would be the parts in the median of the graph, the middle parts, I'm going to put my asymptotes. And then at the peaks and the valleys, I'm going to put my points. Oops, there we go. I'm going to put my parabola type shapes. They're not really parabolas, but they just look like kind of parabolas. Okay, that's why I say parabola type shapes. And that is that graph, 3 cosecant of x plus pi. Okay. So again, I graph the sine function first as a dotted line, and then put this cosecant function on top of it. Okay? All right, let's try another one. Go back to blue. Okay, so this is secant. I'm going to graph cosine. So, again, the period did not change because nothing is being multiplied or divided to the x value. So it's going to be at 2 pi, pi over 2, and 3 pi over 2. Okay, there is no horizontal shift because nothing is being added or subtracted on the inside of the parentheses. So that's nice. Now I got to figure out what the first point is. So I have -2 times cosine, which starts at 1, plus 2. So -2 times 1 is -2 plus 2 is equal to 0. So I'm going to start this graph at 0. All right. Now cosine usually starts going down, but there's a negative sign out in front of this 2, so that means I'm going to go up by 2 more, down by 2, and down by 2. So I'm going to graph my cosine function with it as a dotted line. Okay. Now, through the middle median parts of our graph, which are these 2 points, I'm going to put my asymptotes so I can start drawing my secant graph. Now, a quick note about all this stuff. I'm looking for, when I'm grading these on your summatives or formatives, that you've actually put down the cosine graph and that you've actually put the asymptotes in the right spot and made the cosine graph dotted. All that stuff is stuff that I'm looking for to grade. Okay, so if you don't put it down, that's not good. All right, on with the graph. At our peaks and our valleys, we have our points, and draw our parabola type shapes off those points. There we go. That is -2 secant of x plus 2. Let's go back to blue. All right, a couple more examples. So we have cosecant. We're going to graph sine instead. So this time we do have a period change because it's 4 times x. We have 4x is equal to 2 pi. 2 pi being the default period for a sine and cosine graph, which means it has to be a default period for secant and cosecant. Divide both sides by 4, and we'll get pi over 2. So our period here is pi over 2. Half of that is pi over 4. Half of that is pi over 8. And 3 times pi over 8 is 3 pi over 8. Next, horizontal shift. There is no horizontal shift because nothing is being added or subtracted on the inside of the parentheses, which brings me to the first point. I have negative times sine, which starts at 0, minus 1. Well, negative times 0 is 0, minus 1 is equal to -1. So this graph will start at -1. All right. Now, a sine function usually goes up first, but this has a negative sign in front of it, so that means it's going to go down first with the amplitude of 1, then up, then down. Okay. I'm going to draw my my sine function as a dotted line and draw the asymptotes through the median pieces, or the median points. Change colors for the points that I'm going to do the peaks and the valleys. So here's my valley, here's my peak, and the parabola type shapes go off in the opposite directions. There you have negative cosecant of 4x minus 1. Okay, number 6. So we're going to graph a cosine function. Now nothing is being multiplied or divided to the x value on the inside of our function, which means the period will not change. So we can start with 2 pi, pi over 2, and 3 pi over 2. Okay, a horizontal shift. There is a horizontal shift because it's negative 3 pi over 2 inside the parentheses, which means I'm going to be going right by 3 pi over 2. So this is going to be causing a problem because I'm going to go off the graph. There are 3 intervals between the y-axis and 3 pi over 2. 1, 2, 3. Which means I have to add 3 intervals to my graph going right. So I'm going to have, if this is 1 over 2, 2 over 2 is 1 pi, 3 over 2, 4 over 2 is 2 pi, this is 5 over 2, 6 over 2 is 3 pi, and 7 over 2. So I have to add like a little box over here. Okay, it's fine. It'll work. Okay, so we have our first spot for our horizontal, or point for the horizontal, and I'm going to figure out what the vertical is. So to figure out the first point, 2 times cosine, which is at 1, gives you 2. So at 3 pi over 2 and 2 is where our graph begins. Then we use the amplitude to find the rest of the points. Cosine goes down by 2, and by 2 again, then up by 2, and up by 2. Okay. We draw our dotted line graph for the cosine function, and then we draw our asymptotes. So I'm going to actually draw the asymptotes in a different color because that one line at the end will make it confusing. So the asymptote is in those middle points. or cosine would normally be 0. And then the peaks and the valleys are the points where the parabola type shapes start from. And there we go. 2 secant of the quantity x minus 3 pi over 2. All right, 2 more examples. Hopefully these are helping you out. If you want to just stop the video and try the examples on your own and then look to see how you did, that would be a great idea. All right, so here we go. This time x is being divided by 2, so we have x over 2 equals 2 pi. And we are graphing cosine first. Multiply both sides by 2, and x will equal 4 pi. So that is our new period. Let's go down here and do 4 pi. Half of that is 2 pi. Half of that is 1 pi. And 3 times 1 is 3 pi. There is no horizontal shift in this, so we don't have to worry about that. We go to the next step, is find the first point. We have negative 3 times cosine starts at 1, and that equals negative 3. So our graph is going to begin at negative 3. Cosine usually starts down, but because there's a negative sign here, that means it's going to be reflected up. So we're going to go up by 3 again, down by 3, and then down by 3. So here's our dashed line graph of cosine. All right, I liked the asymptotes of different colors, so let's do that again. Again, if you can graph sine and cosine, secant and cosecant is really pretty simple. The question is, can you graph sine and cosine? So there is our graph. Again, making sure that sine or cosine graph, that's the basis for your secant and cosecant graph, is the dashed line. All right, let's start it below again. Last example. All right, nothing is being multiplied or divided on the x terms. That means your period will still be 2 pi. Okay. Horizontal shift, we're going to go to the left by pi over 2. So between the y-axis and pi over 2, there is only one interval. So I'm going to go one interval to the left at negative pi over 2. So on the horizontal, that's where our graph will begin. Now let's figure out where the graph's going to begin. Vertically. So the cosecant is really just sine. So sine starts at 0 plus 3, which gives you 3. So we move up to 3. The amplitude of this graph is 1, so we're going to go up by 1, down by 1, down by 1, and then up by 1. Make our dashed line graph. And let's change the color for our asymptotes. And then at the peaks and the valleys, we draw our points and our parabola type shapes. And that's it. So again, if you can draw cosine and sine, secant and cosecant should be a breeze. All right, please try the practice and ask questions if you need help.